Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we graph functions in standard form. Now remember, standard form is this form f of x equals ax squared plus bx plus c. And in the previous video, we kind of talked about what this standard form is and some of the identifying properties of it or characteristics. So when our a value is positive, remember it's going to open up. When our a value is negative, it's going to open down. This c value here is going to be our y-intercept, or tell us where it crosses our y-axis. To find our axis of symmetry, or the x-coordinate of the vertex, it's going to be the equation x equals negative b over 2a, and that's also our axis of symmetry. The way that we are going to graph these is we are going to first find our axis of symmetry. So let's find that axis of symmetry of this function here. So remember, the axis of symmetry is x equals negative b over 2a. So I'm going to substitute those numbers in, negative 6 over 2 times 3. A negative times a negative is a positive, so I have a 6 over 6, and that equals 1. So I know that my axis of symmetry, or where this is going to be focused, is right here at x equals 1. My function is going to be symmetric right there on either side. Now, the second thing I want to do is I want to find my vertex. So this will tell us where we are. Notice how this 3 here is positive. That means that it's going to open up and our vertex is going to be at the bottom of our quadratic. So to find that vertex, we know our x value is going to be 1. All I have to do is substitute my x value into my function and I can figure that out. So what is the function when x equals 1? Well, that's going to be 3 times 1 squared minus 6 times 1. Plus 5. 1 squared is 1 times 3 is 3 minus 6 plus 5. Well, that is going to be 2. So our vertex is here at 1, 2. So on my graph, I'm going to put a dot here at 1, 2. The next thing that I'm going to do is I am going to substitute in 2 to 3 values into my equation and then graph them. So as we do this, the reason why we want to pick these values is notice our axis of symmetry is at 1. So if I pick numbers that are 2 or 3 numbers that are after 1, so 2, 3, 4, then that means it's going to be symmetric on the other side. So wherever it is at 2, it's also going to be the same at 0. Wherever it is at x equals 3, it's also going to be the same at x equals negative 1. It's going to be symmetric about that line. Now, plugging these values in, we can look at it a couple different ways. One thing I'm going to do is I notice that I have a plus c here. That plus c tells me that at 0, I'm going to have a y-intercept at 5. Now notice how it's symmetric. So as I went over 1 to the left, I went up to 5. The same thing's going to happen if I go over 1 to the right. My other point is going to be up at 5. Now let's look at one other point here. So the other point that I'm going to look at is I'm going to look at the number -1. So if I put -1 into my function, I have 3 times -1 squared minus 6 times -1 plus 5. -1 squared is 1 times 3 is 3. -6 times 1 is 6 plus 5. Well, that gives me 6 times 5 is 6 plus 5 is 11 plus 3 is 14. So that means I'm going to have another point 6, 7, 8, 9, 10, like way up here, right? And so is this other point because it's going to be symmetric. So my function is going to end up looking something like this. Okay, so the easiest thing to do is graph our axis of symmetry, find our vertex. After we find our vertex, what I like to do before I even substitute these numbers in, to make this even easier on us, what we want to do is graph our y-intercept. And then we want to plot the symmetric point. And that symmetric point is going to be the one that's the same distance away. So in our case, it was 1 away from our axis of symmetry. So the symmetric one was also 1 away, but in the other direction. Then after that is when we are going to plot another point. Right? And this will always help us get that function shape. So what I want you guys to do is try graphing this next one. I want you to try this one on your own. So remember, first we want to find our axis of symmetry and we want to graph it. Number 2 is that after we find our axis of symmetry, we want to graph our vertex. And then after we graph our vertex, we want to graph our y-intercept and its symmetric pair. So whatever that one on the other side is. And then lastly, we are going to substitute values in and plot those points. And basically, if you have 5 points plotted, so your vertex, your y-intercept and its symmetric pair, and then one other number, you should have a good idea of what your vertex looks like. So I want you to work this out on your own. Try this one, pause the video, find that axis of symmetry, the vertex, your y-intercept, that other symmetric point, substitute another value in. After you've finished, unpause the video, come back and check to see if your graph looks like mine. If it does, awesome, you're getting this. If not, see where you made your mistakes and get ready to practice again. Okay, hopefully you've had a chance to get this graphed on your own. We want to follow these 4 steps. So I found my axis of symmetry and it ended up being a -1. Then I found my vertex by substituting -1 into my equation here. And I got that my vertex was -1, 3. So that's this point that got graphed right here. That's my vertex. After that, I looked at my y-intercept and that was -2. So I knew if I went over 1, I went down to -2. Same thing in the other direction, over 1, down to -2. That's my symmetric pair point. And then I substituted in one other point, and that point was when x equals 1. And I got that when x equals 1, it's going to be -17, which is way off my graph. 1 was only 1 past my y-intercept, so the other number 1 past my y-intercept is also going to be way down there. And that is what this is going to look like when we graph it. So that is a quick review on how we are going to graph these. So remember, we have these steps here. We're going to start by finding our axis of symmetry. Then we're going to find our vertex, and we're going to graph our vertex, draw our axis of symmetry, then figure out where our y-intercept is, plot it, then figure out its symmetric pair. So what's the other one that's the same distance away? And then find one other point that will exist and plot that one and its symmetric pair together. And that is how we are going to graph these quadratic functions in standard form.